I have no idea. It's just weird. I don't... All right, so we are refreshing one-to-one functions and inverses. Okay, so one-to-one functions basically say that for every input, there is only one output. Okay? The easiest way to kind of visualize this is with like nested circles. So if you want, I can draw it down here. So when it comes to kind of visualizing what this means, you've got some kind of relation, right? So that could be x equals 3 and you've got a vertical line. That's technically a relation. All right, what would be one subset below a relation? What about a function? Okay, aren't functions specialized relations? They only pass a vertical line test. So now we've got function. Then we've got one-to-one. And it looks like a dude crying right there. Because I couldn't fit one-to-one written out. One-to-one means they pass both the vertical and the horizontal line test. Okay? So looking at this example that I've got right here, is this function, the set of data points, is it a one-to-one function? I've got some people nodding yes, yes. So you always start by check your x's, and we're looking for duplicates. So duplicate x's, duplicate y's. All right, if both of those, I lost my mic. If both of those end up being no, like there are no duplicate x's, there are no duplicate y's, then it is definitely one-to-one. I clicked red, you stupid thing. Give me red. Easy peasy lemon squeezy. All right. Up next, we've got the horizontal line test, and then we've got a couple of examples. All right, so horizontal line test just is a visual representation of showing that for each x, there's only one y that matches with it. All right, so we've got two example functions that we want to look at. Are we ready to look at those or not quite? Good? Okay. So I don't know about you guys, but I kind of like drawing them, especially if we just talked about the horizontal line test. That's going to make my life a little easier. So if I'm looking at x squared, what shape does that make? Happy face you. All right. Does that pass the vertical line test? So it at least narrows it down to a function. Does it pass the horizontal line test? No. All right, so because I've now hit here and here, this is not one-to-one. All right, for a cubic, what shape does that make? The squiggly goes up on the right, down on the left. Does that pass the vertical line test? Does it also pass the horizontal line test? Yes. Now, the one thing I will tend to get asked by students is, well, what about this little area? It kind of looks like it might hit twice. No. When I do horizontal line test, I make it very apparent that it fails. If you're kind of like, but it could if I zoom this in really, really big. Okay, first of all, we don't have zoom on the paper. Sorry, it's not happening. Second, if you zoom anything in stupid close, you're gonna start noticing that things look like they cross because you're now down to pixel by pixel, right? So if it's not very apparent, it passes. All right, so this function is 1-to-1. So far, so good? Okay. So I've got a couple theorems, and then we're going to start talking about inverse functions. Yeah. So they just call the interval I because they're math teachers. They're real creative with it. All right, we're ready to go through and talk theorems now that we've written them down? All right, so that first theorem says, and the second theorem essentially says the same thing. If you're looking on an interval for a function, if it's increasing or decreasing on that interval, then it will be 1-to-1 on that interval. So if we think back to that quadratic function from earlier, if I look at the interval from 1 to 7, is it increasing on that interval from 1 to 7? Yeah. So it's going to be 1-to-1, but just on that interval, okay? So you can be 1-to-1 within a portion of a function, but not over the entire thing. Does that make a little bit more sense? Same with the decreasing. If it's decreasing on an interval, it's going to be 1-to-1 on that decreasing interval, just maybe not the whole function. So far, so good? Kind of, sort of? All right. What do we remember about inverse functions? Anything? Me? Yeah, so it's a reflection over the line y equals x, and that's why we flip x and y when we're solving algebraically. So it is a reflection over y equals x, and that is why we switch x and y values. All right. Inverse functions also undo each other. So think about, there's an example coming up where we're talking about cube and cube root. Those are inverse functions, yes? And they completely undo each other. So that's always something to keep in mind. Like sine and sine inverse. Those functions undo each other. Notation-wise, I did get asked earlier today, well, what if they're talking about like the reciprocal of f? I'm like, that would be really vicious for me to write that the same way I make you guys write inverses. I won't do that. I'll just tell you, find the reciprocal of this function. Okay? So, I got some steps on how to solve algebraically. Can I go past how to find algebraically? All right, so now that we're working on finishing writing, is anything that I've given you, like, new? Because we've found inverses before, yes? Yeah, so switching x and y, okay, fine. If I've got a picture, flip it over the line y equals x. Cool. If I've got a table, switch your x and y values. Also fine. The biggest new thing is going to be domain and ranges, and if you think in terms of how domain and range are impacted when you change the x and y value, I clicked the blue pen. Why? All right, the domain of f would make sense for it to equal the range for the inverse, because if it starts as x over here, that's going to become the new y value for my inverse. Okay? We about ready to hit that example? And we can go over the test when we're done, but I figured I'd pass them out. All right, ready to look? So they give me an example. We're assuming this is f of x. How many of you are looking at this and you're like, okay, that's way too many commas, way too many parentheses, and oh my god, why are there squigglies? Is that a little overwhelming, the way it's written? Yes? No? A couple? So one of the things that you can do is you can actually switch this and write it in a table. So f of x and just pull your x and y values as you go through. So -3 was x, -27 for f of x. But in my math lab, you're going to have to do all the parentheses and the commas, and I'm sorry. All right, so when it comes to finding the actual inverse, make your new table. And then I always do f inverse of x when I write it. And don't overcomplicate this. There is no work necessary. You are just flipping -27, -3. What do we think? Easy enough? Okay. So the next example I've got is verifying that these two are inverses, but let's be real. Looking at them, you're like, okay, yeah, I've got a cube root and a cubic function. Those should be inverses. And the easiest way to do it is switch your x and y and solve for the new y. So do we want to do a different one as more practice? Okay. How about we try this one? And do you guys want to do this with me? Do you want to do this with your neighbors? You're like, don't leave me yet, lady. All right. Ready? Which one do we want to do? The function on the left or the function on the right? Or do we want to do both so we know how to solve them both ways? Both? Okay. So I'm going to color code this one in green. So I've got x equals 1 over y minus 1. All right, switched my x and y. Now I got to solve for y. When you're dealing especially with rational functions, that's when you're going to want to use a lot of your cross multiplication. With these two, it makes life a lot easier. So, technically this is x over 1. 1 times 1 is 1. And then I've got x times the quantity y minus 1. Now, can I be a little lazy and divide by x on both sides, assuming x is not 0? All right. So in doing that, those cancel, and I'm left with y minus 1 equals 1 over x. And my final step is just to move the 1 to the opposite side. So I get y equals 1 over x plus 1. Hey, look, that's my other function. Not as bad as we were expecting? Yeah, you're solving for the new y. All right, so if I go with this one, I've got x equals 1 over y plus 1. Do you guys want to try this one on your own? You still want to try it with me? Try it on your own? Okay. How we doing? We okay? Not okay? We got stuck? We're good? Bueno? Less scary than initially thought? Yeah? Okay. We're almost done, and I've got stickers for the last part of it. So. And the new stickers that are on the test are scratch and sniff as well. We've got new flavors. Some of the flavors I'm a little traumatized by. So from the pack, it starts with lavender, orange, cherry, apple, banana, mango, rose, lemon, normal, right? Strawberry, watermelon, bubblegum, raspberry, blueberry, grape, corn. Yes, corn. Well, yeah, the popcorn ones last year, like everyone started making cat noises like they had a hairball when they sniffed it. I was like, well, you don't have COVID, that's for sure. But we ended up throwing out all the popcorn ones, so I'm a little terrified to smell the corn ones. I don't think I've given any of those out. All right, what do we think? You want to try these with me? You want to try them without me? With me? Which one? Left or right? Right? All right. So this one, I've got x equals 2y plus 1 over y minus 1. Since I brought up the horrible smelling stickers, I'll get those out. You still get a sticker. It's just stinky. The blueberry ones, I was like, oh, that's cool. And then I saw corn, and I was like, I'm not okay with this. All right. So when you go through to do this, I've got x times the quantity y minus 1 equals 2y plus 1. Here's the problem with this one. Because you have a y on top and a y on the bottom in your rational expression, you've actually got to distribute this through. Yes, it's ugly. It's going to be okay. So I got xy minus x equals 2y plus 1. Now I'm going to move everything with a y to one side and everything without a y to the other side. So I'm going to move the 1. And I'm going to move this y. Oh, God, I can smell that from here. So now I've got negative x minus 1 equals 2y minus xy. Can I pull a y out of both of these? I like that. Ooh. Brilliant. Remember, I'm not lazy, I'm efficient. Y, 2 minus x. Now I can actually divide by the quantity 2 minus x, so y is completely by itself. So yes, it looked icky right here, still ended up being a little easier than I think we expected. So I'm left with negative x minus 1, 2 minus x equals y. Now, I will tell you the book might factor a negative out of the top and out of the bottom, so they can simplify it. All right? So if that happens, and I pull a negative, I'm going to work a little over here, because why not? I've got negative x plus 1, and then on the bottom, you'll get negative, and it'll be x minus 2. You guys see this? So this is how they flip-flop the order when they see something like 2 minus x, and they're like, that's not in the right format. Okay? And then because it's a negative divided by a negative, it ends up being a positive. Now, algebraically, I'm fine if you leave it like this. If you chose to go one extra step, you could do that. Okay? Do you guys want to try the f of x on the left with your neighbors? Mm-hmm. All right, and if you would like, I've got smelly stickers. Don't take them. You've got the simplified one that I did. Right, you're still technically correct. It's just what you... All right, well, I haven't heard people start dry heaving yet. Did everyone get to smell it that wanted to smell it? I feel like some of you are like, yeah, I'm not trying that. Pass it behind you. You might need to scratch them a little more with your finger to get the smell to come out. Any of them? Because this one's linear. It's y equals mx plus b form, right? I heard it's not bad, but it's not, like, appealing. Yeah. Yeah, it gets a little rough. Yeah. I might actually have a popcorn one from last year, because... Oh, like the... Remember the jelly bean ones? Yes. I think this one is one of the popcorn ones from last year. Hang on. Oh, God, yep, that's it. All right, we are almost done. We got these last two, and I got stickers. Good stickers. Oh, smell the sticker at the top. And then cry a little. And then pass it on to somebody else and let them sniff it. All right. when you get your test back and I've circled like the instructions that we missed. You smelled this? No, it does not. It smells sad. Yes. I know, right? Smell the regular corn. Yeah. Corn itself isn't bad, but when you smell that one, you're going to be like, ugh. Well, popcorn and corn, they're kind of made from the same one. Do you want to? That's the real question.
Corn's worse.
You think corn's worse? Well, that's like what the pictures are. Yes. Corn scent. But, because why not? I mean, that one's been up there for a year. Yeah. We'll do natural gas, sewage pipe, Mia's dog, my puppy. Yeah, that'd be torture. I know. It's so bad. We should also figure out, like, what other ones we want. Like, for the Birdie Bots. Flavored beans, but for scratch and sniff stickers. Alright, ready? Ooh, porta potty on a hot day. That's vicious. Alright, so we got these last two. Alright, so we got the sticker on the right, and then we've got these two questions. So, for this, I tend to actually write out points. Yeah, the one on there is popcorn, but it's not popcorn. Yeah, that's going to be the inverse. So, someone give me some coordinates. Flip, dude. -1, 0? Okay. -1, 0. Flip it to find the inverse. 0, -1. Alright, so in looking at this, we have to start off with f of x. So what does f of x equal again? 0. And then I've got to find f inverse of 0. What does f inverse of 0 equal? Okay, -1. So you're plugging in the x value of 0 and it spits out a -1. Doesn't that kind of lead me right back to where I started? It's like the song that never ends. Just circles around and around and around. Yeah. This is how, like, I prove to you guys that it actually works, because a lot of times you just write it down and go, okay, yeah, lady. So by using points and being able to flip-flop it, you guys are able to go, oh, yeah, that makes sense. All right, so for the next one, I've got f inverse of x. Okay, so f inverse of x equaled -1. And then I've got f of -1. So when x is -1, what does the function f spit out? 0. Leads me right back to the beginning again. See it? Now, there is one little caveat to this, and this only works on one-to-one functions. Okay? Think about a quadratic. If I gave you a y value of 3, but you had 2 3y values, how are you going to know which side I'm on? Does that make sense? So I would write yourself a little note down here that this only works for one-to-one. Yes? Which one are you looking at? Okay, this part. So f inverse of whatever x is, right here, is 1. Well, when I go back up to f of x, I plug -1 in. It spits out 0. Remember the one on the homework where you guys had the table and you had to do the composition where you're jumping around? Same kind of deal. Okay. All right. Ready for our lovely little graphing one? So what have we been doing with all the x's and the y's? Flip them. So if I have 2, 1, my new point is going to be at 1, 2. If another point was at negative 1, 0, my new point's going to be where? Yeah, 0, negative 1. And then my last new point started with negative 2, negative 1. What does that move me to? Negative 1, negative 2. Line. And does that still look like a reflection over the line y equals x? Yep. So, if you were to take your paper and fold it like this, you would have your line of symmetry at y equals x. And you're good. Score? Done. So yes, you guys did get your test back.